So you're also very familiar with this second approach where we are going to create a dummy variable for different sections of our covariate of age. And another way of talking about this is just a step function because it can look like steps. But really, again, we're just going to cut our covariate into distinct regions to create a dummy categorical variable. And again, this is just essentially fitting a piecewise constant function for each part, right? So it's going to be a flat line, essentially, with different intercepts or different levels for each age. And this provides a simple way for us to fit a nonlinear model, right? And the nice part is that we can also have a pretty good interpretation, but we're also constrained by the placement of cuts, right? Like we need to do that. But like I said, it has an intuitive interpretation. So there are pros and cons of both strategies. Now, a very simple way to do this with age is just going to be allowing R to cut it arbitrarily into three distinctive categories. And when we use the function cut, you can see here that we broke it into categories that range from 17, or basically 18, right, up to around 38, and then around 38 up to around 59 or 60, and then 60 onward to our oldest person, which was 80. Then you can see here that we're just rerunning our regression with our dummy variable that has been generated by the function cut. And here I am just showing you the predicted probabilities again. Now you can kind of see why we're calling it a step function rather than a dummy variable in this instance, just because it kind of looks like steps. But the important thing to note here is that we find, at least substantively, a very similar result than what we found when we use the polynomial transformation, and that is that when individuals get older, they tend to make less money, and there is a nonlinear effect here where there's decreasing wages after a certain time period.